Welcome to this class session about data management and business intelligence. In essence, we're going to talk about how we manage and analyze data. So data management first, we've already covered earlier in the class a little bit about databases. Today we're going to look a little bit more in terms of the core principles for how to handle the data or data management. First of all, a little information about relational databases. We talked about it earlier as well. Just want to remind you that when we talk about handling data, we normally talk mostly handling data in relational databases. And a relational database is built up of different types of tables or worksheet if you have. And then we have some of the keys that are linking together these different tables. And I can see here we have a data sheet, for instance, called tracks with a track number, which identifies each of the rows. We have a recordings worksheet with recording ID that defines each of the rows, and so forth, musicians and categories. Now, when we can relate different identifiers to each other, then the different tables are related. So they are related through these different keys, and that's how the different data in a database is related to each other, and that's why it's called a relational database. Information are used at many different levels in an organization, and here you can see a diagram that we have an individual, department, or enterprise information level where we deal with individual knowledge, goals, and strategies, department goals, enterprise revenue, expenses, processes, strategies, and that type of information. Then the second level we talk about are information formats. And that is what format we have the data in. That could be as document, as presentations, in spreadsheets, in databases, and other forms. The type of information we're talking about here would be, for instance, letters, memos, and faxes. Could be products, could be processes, financials, could be sales and marketing information, could be customer employee information, order information, and things like that. And then on the bottom level here, we have information granularities. And that is to what level we're looking at data. That can be data reports for specific salespeople. It could be reports for all products and all salespeople. And it could be reports across departments that summarizes the types of data that we're working with. In essence, when we handle and use data, we use it for a purpose. So data management is about capturing the transactional information. Could be from airlines ticket boards, could be from sales receipts, could be from packaging slips, or other fundamentals that develop data. And then we aggregate it so we can analyze it and use it for different types of decision making. So the database and the data management is the middle step here between the transactional information and the analytical information. And when we manage and use data, we select, aggregate, and analyze the data for different purposes. Now, the core elements of data management is typically called the data warehouse, and that's where we store and make data available for businesses. So here you can see that data warehouse typically consists of a number of internal and external databases. So that's databases that captures information. In this illustration, you can see the internal databases could be marketing information, sales inventory, and billing information. You can also see that external databases can be linked to a data warehouse. External databases could be databases with competitor information, industry information, mailing lists, stock market analysis, and other types of external data that we would like to include in our data when we want to analyze it and make decisions. You can see the data warehouse structures that data in different kinds of elements. So in this case, we could have an area where documents or data is stored that's relative to marketing, to inventory, to sales, to billing, and so forth. So you can have a unified list of information, a standardized list. So you have a structured overview of the data that you have. And then In the data warehouse, we typically produce subsets of the data relevant for the different types of decision makers. So here you can see that data from the data warehouse, or a subset of the data, is put into a marketing data mart, or a marketing data warehouse if you want. Some information is put into the inventory data mart or data warehouse, and some information are put into the sales data mart or the sales data warehouse. And so normally salespeople, sales managers would use predominantly the sales data mart or the sales data warehouse to do their work, whereas the marketing department would use the marketing data mart or marketing data warehouse in order to do their decision making. So these marts are subsegments of the big data available in the big data warehouse. You can see the title here, ETL. That is something that connects the database with the data warehouse, and the data warehouse with the submarts that we have. ETL stands for extract, transform, and load. So that's kind of the conversion of the data from one to the other. So that's what this abbreviation stands for. And here you can see a real life picture or diagram of an example of a company that has different types of data sources. You can see here that the data source for this company is in the form of ERP data from a software called SAP. They also have financial data in the SAP area. Then they have CRM data from Salesforce, which is a cloud-based platform. They have HR data from a software called Workday. And then they have flat files and miscellaneous from a lot of different types of software. And you can probably recognize Excel and PowerPoint on other software formats. And then they have what's called legacy data. This is like older data from older IT setups. In this case, it comes from an SQL server and an Oracle database and other types of information. This is a legacy, is typically older type of information stored at different places. So this would be the data sources that this company uses. Now, then they transform that through an extract, transform, and load function into different types of data acquisition bases, which is then transformed into the data warehouse. So it's streamlined and set up so the data warehouse can structure and combine the data to a unique data warehouse database. Then the data warehouse itself, this one has what's called an application layer where you can manipulate and manage the data. And based on the application layer, then the database or the data management data warehouse can output the types of data for different types of purposes. Before we talked about data for marketing, sales, and other purposes. That's the same thing you see on the reporting layer here. So the reporting layer represents different kinds of inquiries of data or different kinds of data needs from different stakeholders. So that could be data for an OLAP analysis, for reporting tasks, or for data mining projects. So this is an illustration of the same thing for a specific company. Now, today we talk a lot about big data, and that is the flow of large amounts of data instead of just an extract or static sample of a data set. So when we talk about big data, we are actually talking about big data as defined by 4 key characteristics. You can see that on the screen here. So the first one is a variety. So big data is characterized by having many types of forms. So that can come in forms of data. So, zeros and ones or numbers. It can come in text. It can come in photos and videos and audio streams and other types of forms. So when you have many different forms of data coming your way, you typically have a characteristics of big data that's called variety. You can also have a number of different quality levels of your data sets, and that's what's called veracity. The veracity is about the data that can be unstructured or can have poor quality. It could be untrustworthy, could be duplicated. So typically big data also comes in, let's say, in many types of dirty formats. with different types of quality that needs to be handled. So for instance, it could be that we have many duplicates in the data about a customer name or a customer address. And that would be an example of a veracity of data that is of doubt, of different types of quality levels. Some of them are good, some of them are not good, and it's dirty, which means that, of course, they need to be cleaned before they can be used. The third characteristics of big data would be volume. So that's kind of the size or the amount of data that we have access to. Many of you have a server, sorry, you have a hard disk on your PC that might be able to take 1 terabyte of data. But when we talk about big data, we are talking about maybe thousands or millions of terabytes. So the volume of data is also a signifier of big data. And then the velocity, that is the speed by which you generate or a company generates new data. So take this example, for instance. Let's say we have 15 different video cameras on a facility, and it captures high definition TV, and they probably capture like 10 or 15 frames a second of a high resolution photo and put it together with an audio stream. So we will have a lot of data coming our way every single second, and that would be equal to a high velocity of data. Versus if we produce data from invoices where we might have, let's say, 15 invoice data that per day, but that amount of data is very small when we save it as bytes or bits. So that's the 4 characteristics of big data. If you're asked a question about it, it has to do with variety, veracity, volume, and velocity. And these are the different explanations of what that means. Now, another element of data management is, of course, the security by which we handle the data. Normally, information is an organizational asset, and of course it must be protected. And the data management systems we have, they typically have 3 types of features that protects the data. And you probably know that to a certain extent from your own safety mechanisms on your PC. So of course there needs to be a password that provides authentication of the user. There might be different access levels that determines how much you have access to. So for instance, on your PC, you might have a guest user level and you might have an administrator user level. And a user or guest user of your PC versus an administration user of your PC will have different access levels. And then the last thing that we have for databases would be access control. That is a system where we can also decide what you can do with the content that you have access to. So we can, for instance, provide access control by only providing read-only access to certain types of users for the data and that are looking into the database. Now, one of the important prerequisites for making decisions based on data is that the data we have is good and not faulty or dirty. Now, when we talk about good data, we then define it in terms of 5 dimensions. So here you can see that we talk about data as being good when it's accurate, which means that there are little or no incorrect information in the database, when it's complete, so when it's not missing important elements, when it's consistent, so which means that when we aggregate it, it's a correct summation of the different details. So an example could be if all columns equal the true total of each of the individual items or not. It's timely, which means that the information is current with respect to what we need in terms of decision making. So let's say we are talking about making adjustments of our prices based on last week prices, but if we don't have competitors' prices for last week, we don't have timely information. The last one is unique, which means that we only have one number for the same event. I used to work for Siemens, and we did an analysis of the sales in January. Depending on what system we asked, we got 4 different numbers of the total sales for January, which means that it is not unique. So we have to make sure that each transaction, for instance, or each event is represented only once in the information we have, so we can summarize it to the same number every time we summarize it. So that is a description of the 5 dimensions of good data. Now, in a database, when we look at data, it has to be structured in a certain way. We touched upon it a little bit when I introduced databases to you, and here you can also see an example of some of the quality dimensions of how a relational database should be set up. You can see that columns, they are related to different content areas or forms. So basically, we do structure data by column in terms of the types of data we have, and then the input in terms of data comes in rows. So rows are related to different respondents and objects or events that we want to record, and we can have a lot of different rows. We can maybe have 1 million rows, but we typically would not have 1 million different columns because that signifies the different types of data. So the number of rows represent in principle the number of respondents or objects that are being recorded, whereas the number of columns represent the number of subjects or variables of information that we deal with. Then the number of worksheets or tables represents the number of different types of information sources we have in a database. And if you want to estimate the scope of a database, we normally do that by estimating the rows, columns, and number of worksheets and multiplying that with each other. Database sizes is usually reported by the space it occupies. And so that's why if you buy a computer, it's talking about a 2 terabyte or 1 terabyte or 500 gigabytes storage area. But this one normally reflects the number of data cells with data in them. So there's a relationship between how many data cells something has and then the database size. You can see on the illustrations on the right side that in the top, we have a table that has one label in the first row. So you can see respondent, date, name, age, Q1, 2, 3, 4, whereas the one at the bottom actually have titles spread around 3 different rows, so respondent and date and last name. So it's listed in the wrong dimension, right? So the response, date, last name, age, and Q1, 2, 3, 4 should be listed as columns, as not as rows. So this one, in order to fit into a database, needs to be transposed where the columns becomes the rows and the rows becomes columns. And there's actually, if you work in Excel, there's an advanced function in there that can actually do that very simply. So if you ever come across a set of data that looks like this that you have to transpose, so where you have to switch the rows and the columns, that can easily be done in Excel. Now, when we talk about dirty data can be of different types. So data can be duplicate data. It could be misleading data that doesn't correspond with the reality they're supposed to talk about. Could be incorrect data. Could be data that's not formatted correctly and therefore not read correctly by the software. It could be data that violates different types of business rules or expectations in terms of what the data needs to be. Or it can be simply non-integrated data, so data that is not integrated into a system or inaccurate data. So there could be many types of dirty data that we deal with when we do data management. Here you can see an example of what is considered poor or dirty data. In this table, in this database, you can see, for instance, that as number 1 here, there's missing information, so there's no first name. Here on the second one, there is incomplete data in terms of the street. We only have the number, but not the street name. If we go to this one, you can see we have 2 different spellings of probably the same person, Roberts and Robert, and it has 2 different records, which is probably not smart. If you look at the telephone numbers here, you can see that we have a phone number and a fax number that's the same. And would we expect that to be different? Yes, we might. So that could potentially be some wrong information here. And then you can also see here by the phone numbers that these phone numbers do not have area codes in front of them, which means that these records would be incomplete. And then you can see here in an email, we have a phone number instead of an email, which is then inaccurate or invalid information. So that is examples of poor or dirty information in a database. Why do we have dirty data? Well, there could be many reasons for why data gets dirty, but typically we are talking about errors in the data or the missing data. So that's the two major types of dirty data. Why we have it? Well, it can arise at different locations. We normally talk about 4 types of causes. So it can be because of the source, it could be because of the person or machine that are producing the data. For instance, if it's a survey, so it could be that we ask someone about something, but the true value is unknown to who's answering that question. It could also be that the true value or the right data is difficult to obtain, which is why there's an incomplete record. It could also be that the tool used creates the dirty data. So it could be that a software capture an event or some data which is not formatted or set up correctly. Could be usability issues, but when using a tool, it's not being used correct, which is why data that comes out of an incorrectly used tool might have problems in the data. Could also simply be in the transfer. I don't know if you've seen it sometimes that when you get a PDF document attached to an email, you might not be able to open the PDF document because it's been corrupted. And the corruption can actually happen when the data gets transferred. So if someone sends you a new version of the PDF, then you actually might be able to open it. So that is typically an example of a transfer issue. So when the data is transferred through whatever systems or software is transferring the data, it gets corrupted in one form or another. Transfer issues can typically be due to difference in protocols, could be to hardware issues or other things. Could also, as the 4th area, be due to registration error. So that is basically keying or coding errors when it's inputted, or it is formatting errors when you choose and transfer data from one system to the second. In many different situations, when I do business analytics for different companies, we've actually seen formatting issues arise when you copy something from an Excel sheet into a more advanced data mining or statistical software to do the data analysis, where the text might be in numbers in Excel, but it's imported as text into another software that won't recognize the data, and then the data that's just copy pasted into another system is coded as text and not as numbers, and that gives registration issues, especially if it goes into a database after that. So again, 4 typical causes of dirty data. It's a source, it's a tool, it's the transfer, it's the registration of the data that can cause these issues. Now, when we then handle the data, of course, we need to clean it up. So what does it actually mean to do data cleanup? Well, basically, it only involves 2 major phases. So first of all, we have to audit the data and detect whether the data is dirty or not. And then once we detected the dirty data, then we have to correct it one way or another, or edit it, either by inputting data into the missing data area or handling missing data, and then handling error in the data. So the data editing or the data cleanup is typically handling missing data and handling errors in the data. How do we normally do that? Well, there are typically, when we talk about missing data, so data that should be there, but we do not have, we either have the option of either deleting part of the data or imputating, also putting something in instead of the missing data. And the decisions we make depends on the situation, the types of data and the use we have. So there's no uniform way to do it, but there are a number of different strategies that can be applied in the different situations. But in any case, it is a data management decision of how we clean up the data or how we handle the missing data in a database. And we can do deletion and imputation. So we can, remove something or we can input something in the missing cells. Here you see an example of a missing data set. And here you can see, for instance, underage. that we have respondent number 4 where we don't have the age. So the discussion then becomes, what do we do with this respondent? And there are different ways to deal with it, and I'll talk a little bit about that in a second. You can also see in the importance column where you have number 9, we are asking customers here how important things are between the range of 1 and 5, but then we have a 9 that would be erroneous data, because this doesn't correspond to a number that we would accept as good data. So this is an example of dirty data, not in terms of missing data, but in terms of erroneous data. It's the same thing you see in the column of will consider buying, yes, no, maybe. In this one, we have an answer that says don't know, which means that this is not one of the expected answers of yes, no, or maybe. The question then becomes, how do we deal with this one? Can we conclude that don't know means maybe? We could perhaps, if we have good reason to do so. But we will have to decide, of course, what we do with this missing data or this erroneous data if we want to clean up the database. There are a number of different ways to do it. This is my normal cheat sheet. It's called the 7 ways model of how to fix missing data issues. In this case, you can see here we can either remove, and that's typically either done by removing the data cell that we have. It can be by removing the respondent, so the whole row of data where we have a missing cell. It could be disregarding the question or the column, the variable that we are dealing with. So that depends. That's one way to play it. Or we could insert a value that we think is as close to correct as possible. In certain instances, when we do average calculations in order to conclude about something, then we could simply insert the central tendency for the whole column. So let's say we have a question about how satisfied our customers with our customer service, for instance, and if the average is 3.5, then if we have a missing cell, we would input that 3.5 in the cell. That would be the central tendency. Could also be a random data value. So if the average is not good enough, we could just say, if we have, let's say we have asked people about the zip code and we're missing zip codes. If we don't know the location area of a specific person, we could just input a random zip code in order not to skew the data set. Or we could insert the most likely value. More and more often, more advanced software actually looks at a respondent. If then the respondent misses information in one cell, it compares that respondent to everyone else that has responded, and then it identifies which respondent has almost the same type of answers, and then they use the answers of those very similar or most likely the same type of persons. What values do they have, and then they insert it there as the most likely value for the specific data cell. Or we could simply input a data identifier. So let's say a cell is missing, then we could just input a letter or the number 99 in order to identify that this cell is empty, but it is not in real empty. It has 99, but that 99 number stands for an empty cell. So we can tabulate the data based on something instead of just an empty space. Quite often, the missing data identifier is a standard way to quickly clean up a data set. So we can run analysis on it, but where we also can categorize the respondents that we don't have data on with an identifier like 99. Now, if you want to see an example of how data is actually cleaned up in practice, I have a little link for you here for video. You can see the link here. You can find it on YouTube, where I go through a flavor study and a big data set, where I go through how you detect which cells are empty and which cells are erroneous, and then how you exchange or clean up that data set so you have a complete cleanup data set. Now, we, of course, when we have big data sets, so a lot of data coming to us every second of the day, of course, that we cannot go through a data manually to identify and substitute data or input data where we have empty cells. So the manual identification of the quality control of each data cell is not feasible in many situations, which is why we have to set up automated methods for how to clean up data sets. Now, if we have a static data set, which means that it's a data set we get in an Excel file, for instance, and we can look at as subset, we can, of course, do corrections to the data because it's static, because we have time to do it. However, when we have data coming at us all the time, another way to handle missing data is, of course, to set up a system so we can dynamically handle or on the fly handle corrections. In order to do so, we need some software to help us to do those corrections in an automated way, since we cannot handle it manually. If we do manual cleanup, of course, we can use sorting functions to identify the missing data. However, sorting is a very manual and time-intensive way to deal with missing data. So normally, we would actually produce small programs or formulas that helps us identify the missing data. And then we can also set up different programs to decide and input the types of data we would need in order to have a cleanup of a data set. So these ones would be more advanced programs that can automatically detect and correct missing data based on different rules, based on different decisions, algorithms that could do that automatically. And that's a great way to use information intelligence or artificial intelligence to help set up those automatic cleaning programs of data. The next area I want to touch upon for this session deals with business intelligence. So business intelligence is basically what insights we can draw from the data that we have available. So once we have data and have made data available, the next step in order to gain value out of the data will be to analyze it and draw insights. And that is what business intelligence is all about. Now, what does it mean to do analysis? Well, typically it's a series of questions. So we need to know things in order to do things better. So it could be, for instance, that we ask what are the sales or why are the sales below target? And then we use our data to figure out why that is. And a conclusion could be that we have sold less in the Western region of the United States. However, once we have the information that it's the Western region that is lower than other regions, then we might want to know why we sell less in the West. And then we can look into the data again and try to figure out why in the Western region. It could be because of lower sales of product X. But of course, we want to know why did the sales of product X drop. And again, a data search might unveil that we have an increasing or surprisingly increasing number of customer complaints, which means that people are not ready to buy more products and buy less instead. And then we can ask ourselves again, why did the customer complaints increase? And we can dig into that part and maybe figure out that the complaints increased because of an increase in late delivery that went up by 60%. So in this case, we have found maybe one of the root causes to why we have sold less or below target, and that can be simply because of late deliveries increasing in the Western region. So that's an example of an inquiry process where we look at different questions, we analyze the data in order to find the answer. And that is a process of business intelligence reasoning, if you want, or a drill down business intelligence reasoning, it's formally called. Now, when we do data analytics, it's typically sometimes called data mining. So what do we actually do when we mine data? Well, basically, first of all, we have to have an understanding of what business information or insights are needed to do things better. So step number one is always to understand what business issue or what business challenge are we dealing with, or what business question do we have that we need answered. Step number two will be to understand and locate where we have the different types of data needed to answer the business question or to supply information for the decision needed. So once we have an understanding of what data we have and where we might find it, then the third step would be to prepare the data for analysis. And this is where we extract the data from the databases, from the data warehouse. We organize it so we can actually analyze it in a specific specific software. And step number 4 is then to use the data and analyze it. In this case, it's called data analysis, it's called data modeling, where we use the data to produce the type of results that we need. We might use statistical formulas and other things in order to analyze the data. And once we've analyzed the data, we've completed data modeling, we then can draw some conclusions from the data analysis, from the data modeling, and that is what is going into the evaluation. So we're now concluding about the business issue, or we're concluding on the business questions that we have based on the data we've analyzed. And then based on that evaluation and results that are produced, action can be taken. So you know, the insights can be deployed or used for business action, or it can lead us to asking new types of questions to generate a better business understanding, or it can raise new business needs that needs to be analyzed in order to increase our knowledge and improve our decision making. This is what is called a simple data mining model. So if you ever asked about what data mining is, it's a process by which we produce insights for business decisions or business purposes. This model is basically the same type of model, it's just have an expanded set of steps. So this model talks about that the data mining process starts with a business challenge understanding of what is needed in the business. Then step 2 will be planning the assignment. So how do we go about analyzing and mining the data to get a better business understanding? Number 3 deals with identifying what type of data we need, where it is coming from, and whether we have it or not. Number 4 is to locate the data and acquire the data if it needs to be acquired or bought from somewhere. Number 5 is getting the hands on the data and storing it so we can deal with it. Number 6 is preparing the data, cleaning the data, making it ready for analysis. Number 7 has to do with data, the simple data analysis, drawing insights from the data. Number 8 is where we conclude on what the data tells us in terms of the business needs or the business challenge. Number 9 might be a recommendation where we take decisions about the business challenge. Number 10 is deploying the recommendations. And number 11 controls whether we have solved the business challenge from the recommendations. So that is, again, a similar data mining model. It's just a little more expanded. And I normally think this gives a little better granular picture of the normal types of steps when we use data mining to improve decision-making or to manage a business. Now, I have a number of years been asked about what type of analytics or statistical analysis do we actually use when we analyze data. And I think this is one of the better models to get an overview of the types of analytics that companies engage in. So the biggest area of analytics is called descriptive analytics. So that's where we try to understand what type of data we have. We look at how stable the data is. We try to analyze the central tendency, or the average if you want. We look at the spread of the data, and then we look at the data versus some of the benchmarks of what is good and bad, and that's what's called the capability or performance analysis. So for many companies, the by far mostly used type of analytics would be descriptive analytics. There's also another type of analytics that deals with diagnostics. So that digs into why something is happening. We typically talk about analysis of relationships, correlation, and causation. So this is the second area that deals with why something is happening. The third area of analytics is predictive analytics, definitely always used or often used in budgeting. So if you want to predict what's going to happen with your sales, your revenues, your customer satisfaction next year, you'll then need to engage in predictive analytics, typically building an understanding of what matters to the future based on history. That goes into the predictive analytics. And then the last area of analytics, which has to do with what should be happening. So we call that prescriptive analytics, which takes the predictive analytics and says, if this is going to happen, given the data we have, what should we do about it? A lot of the machine learning and artificial intelligence solutions we have creeping up on us in many businesses actually helps us to decide, given this scenario, what should we do in this situation? And that would be an example of prescriptive analytics. These 4 types of analytics actually fit together because you cannot do prescriptive analytics before you can do predictive analytics, and you cannot do predictive analytics before you understand why something is happening. So before you understand relationships, correlation, causation between different variables, and you can't do diagnostic analytics before you know what is actually happening in the situation today. So before you have an understanding of the central tendency spread and the capability of your performance today. So of course, these 4 types of analytics actually hang together. Normally descriptive analytics, diagnostic analytics, predictive analytics are all necessary for you to do prescriptive analytics. So that's kind of how they fit together. In the textbook, there are a couple of examples of types of analytical techniques used in different situations. So if you want to read more about a couple of the analytical techniques we're using, you can read about estimation analytics, affinity grouping analytics, cluster analytics, and classification analytics. So that's a couple of examples that are more detailed in the textbook. Now, again, because the descriptive analytics are so widely used, I wanted to share with you a few more insights about it in case you're interested. So for the students that are interested in what is descriptive analytics in a little more in detail, you can take a look at this description in the class notes. Here you can see it's about being able to determine the data type, stability of the data, the shape, spread, sense of tendency, and capability. And here you can also read a little bit about what the types of analytics or statistics that are used for descriptive analytics. A very important part of analysis and business intelligence is to visualize what the data is talking about. And the visualization is normally the more the merrier. The more illustrations, the better the illustrations and graphs, the better the presentation of insights. You've probably seen this many times. You probably developed graphs and illustrations yourself. But data visualization is, of course, another important part of business intelligence to produce the visualization and presentation of the data. There are many different forms you can choose from. These are just 2 examples. You can see on the right what we call is a rich graph, where we show graphs and have text that underlines different elements, and it's loaded with a number of different types of information and not just a graph without any further data. Or it could be more popular illustrations of data. You can see here, there's a productivity description from 1987 to 2009 that's shown with different arrows and text that goes up. You can see an umbrella that describes the safety net. So there are many ways to presenting, illustrating the data from a business intelligence or an analytical process. Now, to wrap things up, if we want to summarize some of the core knowledge about business intelligence to get an overview. So normally we are talking about the roles and the purposes of a data warehouse. So what is that? So data mart, for instance, a data warehouse, it will be a logic collection and aggregation of information from different databases needed for a specific department or specific type of decision. We talked about information cleaning, which is standardizing information and setting it up so it's not erroneous or have missing data. We talked about business intelligence, which is how you analyze data to find needed information to support business decision making. So those are some of the core concepts related to the roles and purposes of a data warehouse. Second area has to do with advantages of business intelligence for business decision making. Basically, that's about providing managers with the ability to make better decisions based on the data and analysis of the data available. Number 3 deals with the 4 characteristics of big data. We went through them a minute ago. So the 4 characteristics of big data that you need to know would be that it's described typically by the variety, veracity, volume, and velocity of the data. Data mining, number 4, deals with getting access to the data, discovering things in the data and deploying conclusions from the data. So with a very short and overall description of data mining, we would say that it has three elements. It has data, discovery, and deployment as the three major components. Last but not least, the importance of data analytics and visualization when used is clear and is one of the elements that helps us communicate the insights found and the intelligence that's been gathered by the analysis of the data. So there you have it. That is the short description and introduction to data management and business intelligence. For now, hopefully it's been interesting, and that's the end of this lecture. Thank you, guys.